Good evening. MA Philosophy MPY-001 MPYE-001 Block number 2 Unit number 2 Conjunction, Disjunction, Conditional and Biconditional Objectives. The purpose of this module is to introduce students to the classification and symbolization of sentences in symbolic logic. In this context, it may be noted that we use sentences, statements, and propositions interchangeably. Recognition of compound sentences as a distinct class of propositions is a sort of line of demarcation between traditional logic and modern logic, which places symbolic logic on a different pedestal. Therefore, through this unit, we intend to introduce you to the elements of symbolic logic. Various species of compound propositions are introduced which serve as springboard of further study of logic. Thereby, another objective is served. You will become familiar with different techniques which help you to test more complex arrangements. Introduction. We have already discussed in the previous unit the importance of argument forms in modern logic. Several classes of proposition constitute arguments. The complexity of arguments is just without bounds. A good deal of groundwork is required before we confront such arguments, which is undoubtedly an intellectually challenging task. In order to achieve this task, we have to familiarize ourselves with distinction between kinds of propositions and several ways in which sentences are combined, and more importantly, we have to determine the truth conditions of such sentences accurately. These are the prerequisite for further analysis. Modern logic recognizes three kinds of propositions: simple, compound, and general. Let us deal with the last kind first. Propositions recognized by classical logic, viz. A, E, I, and O, are called general in modern logic. Simple sentence in logical sense is equivalent to what is simple in grammar. In other words, a simple sentence consists of one clause only and singular term in the place of subject. Consider these statements. Number one, Rathi is neat. Number second, Rathi is neat and Rathi is sweet. Number one is a simple sentence, whereas second is a compound sentence. A compound sentence consists of at least two components. Hence, compound sentence in logical sense is equivalent to what grammar regards as compound sentence. Of course, the components of compound statement may themselves be compound. It is important to notice one subtle distinction between compound sentence in grammatical sense and compound sentence in logical sense. This distinction has nothing to do with the structure of sentences but with our perception of sentences. In grammar, we are not concerned with the truth conditions of compound propositions, but in logic, it is our primary task. The truth value of a true compound proposition is true, and the truth value of false compound proposition is false. There is a technique of determining the truth value of compound proposition. In effect, the truth value of a compound proposition is a function of the truth value of its constituents. Logic which deals with this particular function is called functional logic, barring a few cases which are exceptions. In all other cases, the truth value of compound proposition is functional. A compound proposition is said to be functionally compound if and only if its truth value is a function of the truth value of its components. In some exceptional cases, we find compound propositions which are not truth functionally uh, truth functionally compound. Consider this proposition: John believes that lead is heavier than zinc. Lead believe that lead is heavier than zinc. This is a non-truth functionally compound sentence. Its truth value is completely independent of its component. Simple sentences, such propositions are not significant in logic. Hence, we shall ignore such propositions. There are different kinds of compound sentences, each requiring its own logical notation. Negation, conjunction, disjunction, conditional, implication, and biconditional are the kinds of compound sentence with which we are concerned. In this module, an exhaustive description of the method of determining the truth condition is attempted. How are compound propositions formed? Sentences are conjoined using connectives called sentential connectives. Symbolic logic has recognized five such connectives: not and or, if then, and if and only if. These five connectives generate respectively negation, conjunction, disjunction, implication, and biocondition or double implication. Propositions are replaced by lowercase letter like p, q, r, etc., or simply p1, p2, p3, etc. Since proposition is the central theme of our study, this is called propositional calculus or calculus of propositions. While propositions are called variables, sentimental connective connectives are called logical constants. Later we will understand that these constants determine the truth value of compound propositions. Negation. Negation deserves our special attention because it is a compound proposition in a unique sense through grammatically it is simple only. It is also a pointer to the exact meaning of and also the sense in which we use the term compound. Let us consider the following sentence. 3. India is not a member of the UN Security Council. This is a negative sentence. It is evident that only in grammatical sense it is simple. Why does logic understand this sentence as compound? This way of understanding stands in need of clarification. Negation is not merely a compound sentence, it is truth functionally compound. As the truth of three depends the truth of three depends upon the truth of some other statement. We must find out what that statement is. Number 4. India is a member of the UN Security Council. Suppose that 4 is true, then 3 is false. If we suppose that 4 is false, then 3 is true. Therefore, we say that 3 is truth functionally dependent upon 4 and vice versa. Earlier we said that PQR are variables. This is so because in their places we can insert any propositions of our choice. If a sentence replaces the variable, then such preposition is replaced by the first letter of first word or any subsequent word. While doing so, we disregard articles or verbs. Further, we must ensure that the same letter is not repeated. This is one step in the process of symbolization. Second step is very important. We symbolize connectives to connective, not symbol dash. Now 3 and 4 become dash and 1 respectively. Since the negation of a true sentence is false and the negation of a false sentence is true, the following truth table defines the symbol dash thus. Table 1. P dash P 1 1001. Hence, the rule of negation is a negation is true if what is negated is false, and is false if what is negated is true. In the symbolization of negation, it is important to remember that there are other words and phrases besides not, such as it is false, it is untrue, and so on. So there are different natural ways of writing negation, such as it is not the case that that indiscipline is tolerated. It is false that an honest man is a man of millions. It is untrue that Indians are lazy. Conjunction. In conjunction, sentences are joined by and A and D. The sentences so combined are called conjuncts. Sometimes propositions are misleading. The statement given below illustrates the point. 5. Sasi is intelligent and a hard-working student. You may be tempted to think that 5 is a simple sentence. In reality, it is a compound sentence. The breakup is as follows. 5a. Sasi is intelligent. 5b. Sasi is a hard-working student. The symbol we use for conjunction in this module is conjunction and not the uh, dot as is customary. There are many other words beside and for and which the uh, symbol a is used. Some of these words are but, yet, both, although, however, moreover, as well as, while, etc. Some examples are given below. Hari is poor but he is honest. PAH. Mm, Hari is it is not yet tolerable. HAT. Sasi is intelligent although not very careful. IA-C. Both Mohan and Mini are students of logic. MAR. Since conjunction is a functionally compound sentence, its symbol A is a truth functional connective. The truth table of conjunctive proposition provides the truth condition of conjunctive propositions. Table 2. PQ A1111000001000. Since the truth table specifies the truth value of PAQ in every possible case, it can be taken as defining the symbol A. We may take note of one important aspect. Conjunction has mathematical properties. Here we are telling A, it is not in actual A. You have to see the notes. It is a symbol looking like A. That is, a conjunctive function is commutative, associative, or distributive idempotent. PAQ if and only if QAP commutative. PA PA कोष्ठक QAR if and only if PAQ कोष्ठक AR associative. PAP if and only if P idem idempotent. In terms of relation, the properties of conjunction can be stated as follows: symmetry, trans, trans transitivity, and reflect reflexive are the relations which conjunction satisfies. It is symmetric in virtue of its commutative property. It is transitive because because if the statement A and B is true and the statement C and D is true, then the statement A and D is true. It is reflexive because if A is true, then A and A is also true. A relation which is symmetric, transitive, and reflective is known as equivalence relation. Therefore, conjunction can be said to satisfy the parameters of equivalence relation. Disjunction, also called alternation, is a combination of two sentences which with connective or linking the sentences. The two sentences so combined are called disjuncts or alternatives. The symbol used for disjunction is V, called V's. Here are some examples and their symbolic representation. Number 10. Either I will send him an email or I will telephone him. MVT. 11. Either it rain or we shall not go for an outing. RV-G. 12. Either A is not honest or B is not telling the truth. Dash H V-T. The sentential connective V can be used in two senses. A weak or inclusive sense. In this sense, it means not only either or but can be both. Examples: 13. Either Ramu is a cynic or he is a liar. 14. Either Sita is poor or she is sincere. Let us make this inclusive sense more concrete. We can think of a mother asking her daughter to choose one of the two dresses, A or B. The mother wants her daughter to choose one and reject the other. But we will not be surprised if the daughter says that she would take both. In contracts and other legal documents, this weak sense is made explicit by the use of phrase or and oblique or. B. Strong or exclusive sense. In this sense, distinction excludes third possibility. This is possible only when the alternatives stated are mutually exclusive and totally exhaustive. Consider this example. Number 5. Either the line is straight or it is curved. Let us take a concrete example to explain the exclusive sense of or. Suppose you have a guest and you ask him or her, what will you have, tea or coffee? You will be certainly surprised if guest says both. This means that we use both the inclusive and exclusive sense of we, not only in logic but also in our ordinary life. Latin has two different words corresponding to the two different sense of or. Well, inclusive, and out, exclusive. Out, AUT. Exclusive. We use PVQ in its inclusive sense. Well, mm, a weak disjunction is false only if both of its disjuncts are false. Therefore, the rule is number A. At least one disjunct is true. Weak. B. One disjunct is true and the other disjunct is false. Strong. Exclusive disjunction is symbolized by A. H. Lightstone in his work Set Theory and Real Number System in this manner. P V dash Q. PV underline Q. This notation helps us to distinguish strong from weak. Consider the following disjunctive syllogism. Argument 1. UNO will be strengthened or there will be the Third World War. UNO will not be strengthened, therefore there will be a Third World War. It is clear that this argument is valid on either interpretation or of or so we symbolize or by v ways regardless of which sense of or is intended. We can therefore write PVQ and define it as table number 3. PQ PVQ 111 101 011 000. It may be noted here that like conjunction disjunction 2 has the very same mathematical properties. Thus the disjunctive function has commutative, associative as well as idempotent properties. PVQ if and only if QVP commutative. PVQVR if and only if PVQ कोष्टक VR. PVQ if and only if P idempotent. Idempotent property is the same as a reflexive property in mathematical language. Therefore, disjunction satisfies the parameters of equivalence relation. Now, a word about correct punctuation. Punctuation becomes relevant when two or more than two sentential connectives are involved. As in mathematics, in logic also, parent parentheses perform the function of punctuation. Since mathematics is more familiar to you, we shall begin with an example from mathematics. A 5 plus 6 कोष्टक 4, B 5 plus कोष्टक 6 4. It is obvious that A and B are not equal. This is because the preposition of parenthesis parenthesis determine the meaning of the given expression. Similarly, in symbolic logic, parenthesis plays a decisive role in determining the exact meaning of expression. When two and more than two connectives are involved, we should first understand the exact meaning of expression and then use parenthesis properly. Otherwise, we will go wrong. Exercises. So far we have considered negation, conjunction and disjunction. Before we go further, let us work out some exercises. Number 1. If A and B are true sentences and X and Y are false, discover the true value of the compound sentence. Dash, big big bracket, small bracket, dash A V X, small bracket, V is small bracket, V dash small bracket, B A Y small bracket, big bracket. This is how it can be worked out since A is true, dash A is false, and since X is false also. The distinction small bracket dash A V X is false. Since Y is false, the conjunction B A Y bracket is false, and so its negation dash small bracket B A Y bracket is true. Hence the disjunction small bracket dash A V X small bracket V dash small bracket B A Y is true, and its negation, which is the original sentence, is false. We always begin with the innermost component. Implication. Conditional statement. Conditional statement is a compound sentence, compound statement of the form if the train is late, then we will miss the connection. In the strict sense of the term, disjunction also is a conditional statement. However, for the time being, we shall restrict ourselves to the form mentioned above. Other words for the conditional statements are implication and hypothetical proposition. Here we will be using them interchangeably. The component therefore then is called antecedent, implicant, or rarely protasis, and the component after then is called consequent, implicate, or rarely apodosis. In the implication, antecedent is said to imply the consequent, or the consequent is said to be implied by the antecedent. A conditional asserts if its antecedent is true, then its consequent must be true. While symbolizing implication, it is important to identify antecedents and the consequent correctly. Some examples will be of help. A. If it rains, then we shall go for a picnic. R. R is equal to G. B. If it does not rain, then we shall not go for a picnic. Dash R is equal to dash G. Mm, C. You will get the job only if you pass the test. P is equal to G. All the following sentence forms are symbolized as P is equal to Q. Q only if P. Q if P. Q provided that P. Q on condition that P. Q in case P. P hence Q. P implies Q since PQ. P is a necessary condition for Q. P is a sufficient condition for Q. There are at least four senses in which if then is used. Logical, for example. Logical, for example, if all cats like liver and Dina is a cat, then Dina likes liver. Definition. In this sense, the consequent follows from by and very definition of a word. For example, if the figure is a triangle, then it has three sides. Three sides. Casual. In this sense, there is a causal connection between the consequent. For example, if gold is placed in aqua regia, then gold dissolves. Decisional. If you shave your head, then I will change my name. How do we find out the meaning which is common to these four senses of if then? In order to find out an answer to this question, we must ask what circumstances would suffice to establish the falsehood of a conditional. Hence the rule, the conditional is false only in one case. Any conditional with a true antecedent and a false consequent is false. Incidentally, it is important to note that this is the chief characteristic of deductive logic. If all the premises are true and the conclusion is false, then the deductive argument is invalid. A true proposition can imply only a true proposition. The truth condition of implication is represented in the form of a table 4 PQ P is equal to Q 111 011 001 100. This table shows that implication is false under only one circumstance, when a false conclusion is derived from a true premise. Under all other circumstances it is true. Compare any truth table with any other truth table. You will notice that the truth value of any two compound propositions differ through variables remain the same. Compound propositions differ only with regard to sentential connectives. This is an important aspect which proves that only sentential connectives determine the truth value of propositions independent of variables. Here are some examples working out. In all cases, assume that P is 1 and Q is 0. A P is equal to Q bracket VP is equal to 1 bracket 1 is equal to 0 V1 is equal to 0 V1 is equal to 1. B Q is equal to a small bracket P A dash Q small bracket is equal to 0 is equal to a small bracket 1 A dash 0 a small bracket. So is equal to 0 is equal to a small bracket 1 A 1 a small bracket, and then 0 is equal to 1 is equal to 1. C dash small bracket P A Q small bracket is equal to dash Q is equal to dash small bracket A 1 A O small bracket is equal to dash 0 is equal to dash 0 is equal to 1 is equal to 1 is equal to 1 is equal to 1. Material implication. We have considered the different senses of if then. Not all conditional sentences not all We have considered the different senses of if then. Not all conditional statements need asserts one of the four kinds of implication mentioned earlier. Material implication constitutes a fifth type that may be asserted in ordinary discourse as follows: if Gandhiji was a military genius, then I am a monkey's uncle. Conditional proposition of this sort is often used as an empathic, emphatic or harmonious way of denying uh, its antecedent. So the full meaning of this conditional seems to be the denial that Gandhiji was a military genius is true when I am a monkey's uncle. It is a monkey's uncle is false. What it means is simply this: since the consequent is so obviously false, the conditional must be understood as denying the antecedent. The use of material implication is equal to as the common and partial meaning is justified on the ground that the validity of valid arguments involving conditional is preserved when the conditional are regarded as asserting material implications only. It must of course be admitted that such symbolizing abstracts from or ignores part of the meaning of most conditional sentences. but the justification for doing so is demonstrated by some of the rules of inference, such as modus ponens, modus tollens, and hypothetical syllogism. However, if then relation like either or is not as simple as it appears for the ordinary people, and the logicians do not look at it in the same way. For an ordinary person, two simple sentences are related conditionally only under two conditions. One, their meanings must be related, and second, the consequent must follow from antecedent. However, a logician is not particular about these conditions, provided antecedent should not be true. If the consequent is false, the logician's main focus is on the logical properties of an implicative relation. Though the truth value of implication is thus truth value of implication is thus truth value of implication is thus worked out indirectly. The problem is not over. For if we look at the truth value of implication carefully, there appears to be a paradox. The first three rows in it are saying that any sentence, true or false, can imply a true proposition further. Only a false conclusion from a true premise is not admissible. This is the result of the logical properties of an implication. But this is not acceptable to an ordinary person. How can any sentence, true or false, imply any true propositions? This is paradoxical. Similarly, the third row is saying that any sentence, true or false, can be implied by the false proposition. This again is paradoxical, but we must look at the reason behind these paradoxes. In the cases of conjunction, disjunction, negation, and also biconditional or equivalence, as we shall see later, the ordinary language helps the logicians in framing their truth values, but they could establish the truth of implication only indirectly. This, however, does not fit in with the ordinary use of if then, and hence the paradox of material implication. This problem can be solved if we keep the logical standpoint and the ordinary standpoint separate. For logical purpose, we take the former standpoint or if then called material implication. It is quite rewarding to consider a few examples as exercises. This is the only way to learn logic. If A and B are true sentences and X and Y are false sentences, which of the following compound sentences are true? Number one, X is equal to small bracket X is equal to by small bracket. Second, X is equal to X small bracket is equal to by. 3, small bracket A is equal to X small bracket is equal to by. 4, small bracket X is equal to A small bracket is equal to by. 5, A is equal to small bracket B is equal to by. 6, A is equal to small bracket X is equal to B. 7, small bracket X is equal to A small bracket is equal to small bracket B is equal to by small bracket. 8, small bracket A is equal to X small bracket is equal to small bracket by is equal to B. 9, small bracket A is equal to B small bracket is equal to small bracket dash A is equal to dash B. 10, small bracket X is equal to by is equal to small bracket dash X is equal to dash by. 11, small bracket X is equal to A is equal to small bracket dash X is equal to dash A. 12, small bracket X is equal to dash by small bracket is equal to small bracket dash X is equal to by. 13. Small bracket a ax small bracket is equal to by small bracket is equal to small bracket a is equal to by small bracket. 14. Small bracket a v b small bracket is equal to x is equal to a is equal to small bracket a is equal to small bracket b is equal to x small bracket. 15. Small bracket x a by small bracket is equal to a small bracket is equal to x is equal to small bracket by is equal to a small bracket. 16. Small bracket a x is equal to b small bracket ax is equal to aas small bracket is equal to b small bracket is equal to small bracket a is equal to small bracket b is equal to x small bracket small bracket. 17. Small bracket x is equal to small bracket a is equal to by small bracket is equal to small bracket x is equal to a small bracket is equal to by. 18. Small bracket x is equal to small bracket x is equal to by small bracket is equal to small bracket x is equal to x small bracket is equal to x small bracket. 19. Small bracket a is equal to b small bracket is equal to a small bracket is equal to a. 20. Middle bracket small bracket x is equal to y small bracket is equal to x middle bracket is equal to x. Biconditional. A bio A biconditional is a compound statement which is a combination of two sentences. The connective used to obtain this proposition is if and only if. For example, you will catch the train if and only if you reach the station on time. Is a biconditional statement. This is symbolized as C is equal to R. Such statements are true when both the components have the same truth value. A bioconditional is true in two cases only. Both the components must be either true or false, as is clear from the following truth table. Table 5. PQ P is P P is equal to Q 1111000100001. It must be noted that biconditional is a It must be noted that biconditional is a conjunction of two implicative propositions. P if and only if Q is logically equivalent to small bracket P is equal to Q A small bracket Q is equal to P. Truth table assists us to find out how it is so. Table number 6. PQ P is equal to P is equal to Q and Q is equal to P. A Q is equal to P. 111111 1000001 010100001111. Compare the truth values of column 3 and 5 in each row. Since the values have remained the same, we conclude that P if and only if Q is logically equivalent to if P and then Q and if Q then P. Here are some more examples that have similar but logically different forms, and therefore we have to be very careful in symbolizing them. Number one, Mr. X will catch the bus if he reaches on time. R is equal to C. Second, Mr. X will catch the bus only if he reaches on time. C is equal to R. 3. Mr. X will catch the bus if and only if he reaches on time. C is equal to R. Equivalent forms. It is possible to transform compound proposition without changing the meaning of proposition. Such transformation yield equivalent propositions. Let us construct a truth table for each compound proposition to understand how it works. Implication. Table 7. Implication, disjunction, negation. P Q dash P dash Q. P is equal to Q. Implication, P is equal to Q. Disjunction dash P V Q. Negation dash bracket small bracket P A dash Q. 1 1 0 0 1 1 1 1 0 0 1 0 0 1 0 0 0 1 1 1 0 1 1 0 1 1 1 0 0 0 0 0 1 1 1 1 1 0 0 1. The advantage of truth value method is obvious. Without any verbal explanation and with least effort, it is possible to identify equivalence between propositions. The equivalence relation which exists between implication and distinction is self-explanatory. However, relation with negation requires some clarification. There are two columns under negation which reflect truth truth values. Suppose that we ignore negation sign and corresponding truth values and consider the last column, then we are not considering negation but conjunction. The last column in the absence negation proceeding first bracket is the same as the following one. Table 8 PA dash Q 0 1 0 0. However, the required However, the required form is not conjunction but negation. The truth value of negation form, of course, functionally depend upon the truth value of conjunction form. Therefore, while selecting the column which corresponds to negation form, we should exercise a little caution. It is necessary to consider another form of equivalence relation, and this is relevant only with respect to implication. Examine this table. Table number 9. PQ dash P dash Q is equal to P is equal to Q dash Q is equal to dash P. Implication, contraposition. 1 1 0 0 1 1 1 0 0 1 0 0 0 1 1 0 1 1 0 0 1 1 1 1. In this transformation, the components are replaced by their complements and transposed simultaneously. It will be an error to just transpose without affecting the change in quality, because implication does not satisfy the symmetric property. What happens exactly when P is equal to Q becoming Q is equal to P? The reader is advised to construct truth table and see the result. The reader must be in a position to discover the equivalent for, form for distinction. It is plain from table 7, and if P then Q small bracket P is equal to Q is logically equivalent to dash P or Q small bracket dash P V Q small bracket, we shall express in the form of equations. Disjunction is small bracket dash P V Q is equal to implication P is equal to Q. Negation of conjunction is equal to dash small bracket P A dash Q. The formula is simple. Replace the first disjunct by its negation, and simultaneously V by is equal to beget implication. Therefore, the equivalent form for PVQ must be dash P is equal to Q. Contraposition for disjunctive proposition is superfluous because it satisfies the symmetric property. Let us construct truth table for the equivalent forms of this proposition. Table 10. PQ dash P dash Q PVQ dash P is equal to Q dash small bracket dash P A small bracket Q small bracket 11001110 1001110 011011110 It is quite interesting to note that conjunction and bioconditional do not have equivalent forms. Truth table again comes to our rescue to know why it is so. It is sufficient if we consider any one form, say implication, to know why it is so. If one equivalent form is absent, it is imperative that other forms are also absent. Table 11. PQ dash P dash Q PAQ P is equal to Q dash P is equal to Q P is equal to dash Q dash P is equal to dash Q 11001101 100100111 0110 001101011 except that truth values of conjunction do not tally with any possible arrangement in implication form. No other explanation is conceivable for the absence of equivalent forms to conjunction. The students are advised to test other forms with respect to disjunctive syllogism to convince themselves with the veracity of this statement. Why conditional proposition also does not have any equivalent form? This reason is very simple. Why conditional is in reality a conjunction to implication. Two implications. First, we shall know why it is a conjunction. Table 12. PQ dash P dash Q P is equal to Q bracket P is equal to Q bracket A small bracket Q is equal to P 11001111 1001 0001 01100100111 0011111. The method of computing is as follows. First, we shall compute the truth value of first implication small bracket P is equal to Q small bracket, and then we will compute the truth value of second implication small bracket Q is equal to P small bracket. These two sets of truth values together determine the truth value of conjunction. When we compare columns 5 and 7, we will come to know that these two expressions have identical truth values in all instances. It shows that biconditional is also the conjunctive proposition where the conjuncts themselves are compound propositions. Therefore, what applies to conjunction naturally applies to biconditional also. Check your progress. Note: use the space provided for your answer. Number 1, if P is true, then Q is false. Then work out the values of following statements. 1, P is equal to small bracket Q is equal to P small bracket. Second, dash P is equal to small bracket P is equal to P small bracket. 3, small bracket P is equal to Q small bracket is equal to small bracket dash P V Q small bracket. Second, which of the following sentences are true? A. New Delhi is the capital of India or Rome is the capital of Italy. B. New Delhi is the capital of Spain and dash Paris is the capital of France. C. New Delhi is the capital of India. A dash Paris is the capital of France versus France. V. New Delhi is the capital of India. D dash middle bracket dash Stockholm is the capital of Norway. A. Paris is the capital is the capital of Spain. Small bracket middle bracket V dash middle bracket dash London, small bracket London is the capital of England. A dash small bracket New Delhi is the capital of Spain. E Paris is the capital of France. V dash middle bracket New Delhi is the capital of Spain. A dash small bracket dash Paris is the capital of France. A dash New Delhi is the capital of Spain. 3. If A, B and C are true statements and X, Y, Z are false statements, which of the following are true? Number 1. Dash A, V, B. Second, small bracket A, X, small bracket V, small bracket B, V, Y, small bracket. 3. Dash small bracket X, A dash Y, small bracket A, small bracket B, V dash C. 4. Dash small bracket X, V, Y, small bracket A, small bracket dash X, A, Y, small bracket. 5. Dash small bracket A, V, B, small bracket V dash small bracket B, A, small bracket, small bracket. Number 4. If A, B and C are true statements and X, Y, Z are false statements, determine which of the following are true. 1 A is A small bracket B. 2 small bracket A is equal to B is equal to Z. 3 X is equal to small bracket Y is equal to G. 4 small bracket X is equal to Z is equal to C small bracket is equal to Y. 5 is middle bracket small bracket A V X small bracket is equal to Y middle bracket is equal to small bracket X is equal to A small bracket is equal to small bracket A is equal to Y small bracket small bracket. Let us sum up. These are 5 kinds of compound propositions. Compound proposition in grammatical sense is different from compound sentence in logical sense. All compound propositions do not have equivalent forms. The truth of any compound proposition is determined by the truth value of components. Sentential connectives determine the truth value of compound propositions. Thank you.